Assalamu alaikum. This is Dr. Usman Sadiq Paracha, and today we would be having our lecture number 22 of the subject applied quantitative analysis and practices. In our previous lecture, we were basically having discussion on factor analysis, and we ended our factor analysis methodology in previous lecture. And as a whole, we discussed as factor analysis is used to identify the structure or pattern which may be there among the group of items or questionnaire items, and we use it to identify the pattern there if there is any structure available. So in order to identify the dimensions and these patterns, factor analysis is deployed, and then we have to go to certain stages which range from stage 1 to stage 7, and through these stages then we have to satisfy certain conditions for each stage, and after satisfying all these conditions, then the factor analysis is fully implemented, and then the outcome and results become available. Based on that, we basically had a discussion about the application of this method in SPSS, how we use this method in SPSS, and how data is entered, how we give the specification for the different tests within factor analysis which needs to be deployed. Then the interpretation of the results, that's vital, and as we discussed before, that we have to identify the objectives of factor analysis first, whether we want to pursue exploratory factor analysis or confirmatory factor analysis. Once we have identified our objective and within that the unit of analysis, then we are going through the process of designing the factor analysis. And in the designing stage, we have to basically ensure which type of factor analysis needs to be deployed, whether this is common factor analysis or component factor analysis. So it all depends upon how basically and the research design for the study is selected, what kind of theory is being used in this case, what are the theoretical demands, and then whether we want to cover the total variance covered by all the variables in this case or not. So based on these factors, we have to then first choose the method. Now, in this designing phase, once we have chosen the method, then we move towards the further steps, and in those steps then we have to basically decide the number of factors which need to be extracted, and again we can mention exactly the number of factors, or we can also decide this thing based on the statistical analysis, which include the method of latent root criteria and also the percentage variance criteria. So these methods, and along with that the rotation method. So based on statistics, these values can be, and these factors can be determined, and also we can do it from theoretical perspective. Normally it is advised that at first theoretical perspective is seen, and first it must be seen whether the logic of the theory is enough to give us exactly the number of factors which we need to extract from the data set. So once we have gone through that, then we discussed about the rotation methods which are used to refine the groups which have been defined by factor analysis. In this case, we discussed that the rotation basically is of two types, orthogonal and oblique, mainly these two types, and there are other types as well, but basically we are focusing on these two. And then we had a discussion about how this rotation works, and then we discussed about the types, including Varimax, then Cortimax and Equimax methodology, what are their advantages and disadvantages. Now after the rotation phenomena, once we had gone through that, then we had gone through the identification and interpretation of factors which have been basically extracted from the main data set. So based on that, this is vital that we follow the assumptions and conditions, and we discussed about all these conditions in the name of Bartlett test of sphericity, in the form of Kaiser-Meyer-Olkin KMO test and KMO statistic test. These are various tests which need to be justified. They have got certain end limits which need to be justified. Likewise, we also have the limits for commonalities of each variable, which explain the variance of each variable, which is caused by each variable among the whole data set. Then we also discussed about how the factor scores are basically originated through this analysis. Once these factor scores are made, they can be used as a replacement for the mean scores for the items included in any questionnaire. Then there are other types of scores as well, like summated score and then like surrogate variable. Now all of these three have got their own advantages, disadvantages as well. So it depends upon the theoretical perspective, the need of the study or the business research method which needs to be followed, and based on that then we can decide which methodology to follow. Then the important part comes regarding validation of the factor analysis, how we need to validate it, and we discussed that a very typical procedure for such a thing which has been followed is EFA to CFA approach, which is the latest approach, in which first we deploy exploratory factor analysis, we identify the structure through that EFA, and then we validify it by applying confirmatory factor analysis, which again is run in MOS, which is another software. So once the structure which has been identified by EFA, once the structure is confirmed in CFA, then basically our validity of the whole questionnaire is then determined. And normally it is advisable to follow EFA to CFA approach, and once we have gone through that, then another method for verification, as we discussed before, was related to the division of sample into two groups, and then we apply factor analysis on both the groups, and based on that then we can basically determine whether the factor analysis results of both the groups are same or not. Then afterwards, once this is established, the important part is that factor component matrix are also originated, and we can observe from there that what is the relationship in between these factors and how it can impact our determination of dimensions of the main construct which we have been considering in the study. So this is vital that these all factors must be considered, and basically factor analysis is a combination of a lot of tests which are deployed within the factor analysis, and there are quite a number of conditions and assumptions which need to be met before the final structure is observed and then confirmed and validated. So it's a sophisticated analysis technique, and it is very much essential that it should be employed, specifically now when we are trying to avoid multi-industry studies, because now the researchers are pointing out that instead of conducting business research or business study on multiple firms of different industries at the same time, it is advisable to look at each industry separately, because each industry has got its own phenomena, its own structure, its own factors. So this is very vital, that when you are testing each theory separately in each industry, then we have to basically deploy factor analysis to check the validity of the questionnaire regarding each theory, whether that specific questionnaire is really applicable in that arena or not. Now, this factor analysis technique basically is the authentic one to check the validity of any kind of questionnaire used in theory. And based on every industry scenario, again, we may come to the conclusion that the standard questionnaire which may have been tested for multi-industry may not be applicable for that specific specialized industry. That's why that in order to make authenticated changes in a questionnaire, then this factor analysis technique is deployed to check not only the validity, but also to suggest that which kind of questions we need to omit or reform so that the questionnaire tool will become more effective in our study. So these were the different factors and aspects of factor analysis which we discussed in our previous lecture and in our previous lectures also. Now, the next topic which we need to discuss today is called simple linear regression. Simple linear regression is a very important topic, and basically it's the crux of the whole quantitative business analysis. It's very vital, and it's one stage further after the correlation analysis is performed. So coming to the details of this simple linear regression, as you can see, the difference between correlation and regression, we know that the scatter plot is used to determine the relationship between any two variables, and scatter plot in fact is a graphical representation of the whole correlation process. And correlation analysis, again, we are though given figures in the form of R or R square, and it gives us the strength of the association between any two variables. Again, we have also discussed if we want to observe the impact of a third variable on the relationship between the two variables which has been observed, then how to go through that part in correlation. That's why I would say that partial correlation test is also made. We have already discussed it before. So here basically we have already discussed that correlation basically gives us only the strength of the relationship. It also just tells us the positivity or negativity of the relationship there, but it won't give us any idea that which variable is basically responsible for the other variable, or the cause and effect phenomena is not detailed in correlation. So this is a big discrepancy in correlation phenomena, that we will not be able to identify the direction of the relationship, in fact. So in order to have more detailed analysis of the cause and effect purpose, then we move towards regression. But coming to the detail, we have already discussed how there are different types of relationships, and here you can see that in linear relationship we have got a straight line, and you can see how all these values are more closely bonded towards that line, and this in fact gives us an idea of a linear relationship. So as you can see here, this kind of relationship which we are seeing in the diagram is the positive one, which says that there is a positive relationship between x and y, whatever the variables are. Then we are seeing here another diagram in which these variables again are bonded towards each other, towards that line, and again this kind of diagram gives us an idea of a negative relationship between x and y. Now both of these are kind of linear relationship. However, on the other hand, we are dealing with another type of relationship which are termed as curvilinear relationship, which are in the form of a curve, as you can see here in the diagram. Likewise, their direction, their shape of these curvilinear relationship also changes, as you can see in this diagram below. So these are different patterns of different kind of relationships which can be seen graphically, and then we can interpret the relevant options from that. Then again, we discussed before how strong relationships are graphically portrayed here, and in this case you can see that these values are close to each other in both the cases. And likewise, then here again, in case of negative relationship, then the positive relationship, you can see that in case of negative relationship and inverse relationship, all these values are closely bound to the line shape is different. So in case of weaker relationship, we can see here that all these values are moving away from that line, and basically the farther they go from the line, the more weaker the relationship is. Again, in this case, this is a relationship, a positive relationship, which is depicted here, as you can see. But in case of negative relationship, you can see the direction of the line changes. However, as this is a weak relationship, so all the data points are moving farther from the main line. So basically, these are the kind of relationships which we had in mind while we were trying to observe the correlation coefficient of any two variables in this case. So here then there's another example of what would be the case if there is no relationship existing between any two variables. Here you can see that it is depicted by a straight line, which is shown here. Now in this straight line you can see that all the values are scattered around that straight line, which is horizontal in direction. So this portrays that there is no relationship between these two variables. Then in case, but this case is valid for both the cases. Here you can see that in first case the variables were moving away from the main horizontal line. On the other hand, all the other values in the second graph, they are very closely bonded to the one line which is horizontal. In both the cases, this is depicted that there is no relationship which is existing among them. So based on that, we can assume the nature of the relationship between any two variables. And these scatter plots and graphical analysis do give us a faint idea of what kind of result we should be expecting if we are to try a regression analysis on the same data set. So based on that, coming to the regression analysis, that why regression analysis is used. Now in regression analysis, basically we predict the value of the dependent variable based on the value of at least one independent variable, but this is a very basic definition. Normally we need to explain a certain variable by several other variables which may have an impact. So here we are dealing with one dependent variable or more than one dependent variable, and this dependent variable is the variable which we want to explain, which we want to predict. Then on the other hand, we have got independent variables, those variables which are used to explain the dependent variable. So in this case, basically both of these variables are of vital importance. Basically what we are trying to do is that we are trying to measure the impact of independent variables on any dependent variable. Now the phenomena can be portrayed in any basically in any scenario, but it depends upon that what theory, what kind of situation is being kept under observation through regression analysis. Now here basically the model depends upon only one independent variable in case of simple linear regression model. Then again we know that this whole relationship between x and y is described by a linear function, and then again the changes in y are assumed to be related with the changes in value in x. For example, here you can see that, let's say in the example we were trying to study the impact of training on employee productivity. So here you can see that training is the HR practice. We want to study its impact on employee productivity. So here basically you can see that there are two variables which are of vital importance in HR. We want to study the impact of one variable which is independent, this which is called training. So this is our independent variable, and the other, employee productivity, is dependent variable. So we have tried to take the input from respondents from a certain firm, we collected it, and then we put the data in SPSS, and we want to observe the impact of the independent variable or predictor on the dependent variable. So here basically you can see that the kind of model which you can see here, in which there is one independent variable and one dependent variable, so the testing of such a model in regression will be termed as simple linear regression model. So in this sample model, basically we are observing only one independent variable and one dependent. If there are more than one independent variables in the model, then we will term the same analysis and same model as multiple regression model. We will discuss it in future. Now coming to the next part, that what is the basically explanation of this simple linear regression model. Here you can see the main equation which has been formulated, and here the important part is that our dependent variable is portrayed here as yi, and then we are listed with another formula which is the intercept, which is also termed as b naught, and then we are dealing with the slope figure and the independent variable. And you must have basically studied this very basic equation in your 7th or 8th grade, which is written as y is equal to mx plus c. Now here basically this whole equation in m is termed to be the slope. So same here, the exception that we have got an error term which basically is not included in the main equation which we have studied before, and then we are inculcating an additional term which is basically the error term here, and which is of quite importance here. So in this case, again, this is pretty much evident that we cannot exactly predict the dependent variable, and there would also always be concept of error term there in that case. So this whole equation has been derived from the concept of a line. If you must have remembered from your earlier grades of education, what we used to do was we used to draw a line, and basically this equation, which is y is equal to mx plus c, used to represent that specific line coordinates. So same here, in this case we are trying to establish a model, and in that model we are kind of drawing this line based on this equation which is displayed here. Now here, what's the explanation of this equation in this case? So in this graph you can see a clear depiction of the equation which we discussed before, and here basically we have magnified all the original values which are represented here in this form, and here basically we have divided the whole line into different aspects in order to explain the equation. Now here you can see that this single point basically, which is represented here, its value extends from that value to the x-axis. Now the value below the line, which is drawing here, is the one which is explained, which is pretty much evident that this model can explain. However, the area which is above this point to the value basically is the one which has not been able to be explained in this model. So this much area basically is termed to be unexplained, and this such kind of error which is presented is by eta I, which is random error for this xi value. Then comes another important aspect, which is termed as the slope, which you can see here, and this slope basically lies in this side in this equation. Now slope gives us the idea of the nature of relationship between independent and dependent variable, and in this case you can very much see that how this whole system based behind this equation is elaborated here. So this whole diagram basically gives us a very brief idea of how this equation has been formed, and based on that, again we are trying to explain the one variable which is termed as yi naught, and we try to find out whether the other variable has an impact on this main variable termed as y naught I. So here basically the explanation of different figures are there, and you can see b naught is the estimate of the regression intercept, and beta 1 is the estimate of the regression slope. So basically xi is the value of x for observation I. Now here basically this is vital that this equation should be followed in true spirit while performing regression analysis. Any deviation from this equation will make your results biased in this case. Based on this equation, then we are basically going through the method which is termed as least square method. And here we can clearly see that in previous diagram, if you have a look, the values which are above this mean y position, which is shown here, they can be nullifying the values which are below the line in this case. So in order to avoid this sign game, and because of that sign game the values or entities become equal to 0, we basically try to find out the whole answer through the least square method. And in this least square method, B0 and Bi are obtained by finding the values of that minimize the sum of square differences between y bar and y naught. So least square method is most commonly used, very effective. The formula is written here, and based on that we can also calculate the B0 and B1, and B1 formula is written here, so it's more easier for you to calculate these B0 and B1, and then you can deploy it in the equation which is required. So these coefficients B0 and beta 1, which we have discussed before in previous slide, they can be calculated through these formulas which are given, and here you have got the formula for both B0 and B1 respectively. You can find them out, and ultimately you can make your regression equation model in this case. However, now before going through that, we have to interpret the slope and the intercept, and here you can see that the B0 basically is kind of an estimate average value of y with value of x equal to 0, whereas B1 is the estimated change in the average value of y as a result of 1 unit increase in x. Now beta 1 value, which has been projected from the previous data which is entered, that is important, because based on that we try to determine B0 and B1. Both beta 0 and B1 are very much important in determining the size of the relationship, the cause and effect, and other perspective as well. So that's why it's very much important that we first calculate B0 and B1 in any case. So once we have calculated both these values, then our model is complete, and then we can deploy that model to calculate any other values. Now here basically we are taking an example of a real estate agent who wants to examine the relationship between the selling price of a home and its size. So he randomly collects data from the sample of 10 houses which have been selected. Now here the dependent variable is equivalent to house price in $1,000, and independent variable is square feet. So what we are trying to do is we try to find out whether the size of any home has an impact on its price. So based on that, you can see the mixed data which is available, like house price in $1,000 is 245, 312, 279, 308. Now here the square feet basically remains the same, because the higher the sample goes, ultimately the sample calculation gives us now round about the same figure. Now here basically, in order to test this house price phenomena, this is vital that we put it in SPSS and we try to find out the relationship between these two, firstly through correlation. Here basically we are given a certain data in which we are given the house price in $1,000 and basically the size of the house in square feet. Now previously, if you might see that we just wanted to find a relationship between the selling price of a home and its size. So we have taken a random sample of 10 houses. Now here independent variable is size, independent is house price. Now here we are given the data, but again this data is fluctuating, so based on that it won't be that much easy to depict any kind of relationship between these two. So in order to have an initial view, we tried to calculate the scatter plot of the proposed relationship, and here you can see that the values, the few values which have been given to us, they do portray a positive relationship between between square feet and house price. Now here you can see that approximately this straight line can be drawn based on the average values of these data sets. Once this straight line is drawn, then we can easily predict the value in any case. So once we have gone through that, then we are being displayed the result of a simple linear regression. And here you can see we are given some coefficients of the model, and in this case one coefficient is intercept, which is in the form of 1998.24. These again, these coefficients of square feet is being shown is 0.10977. So these coefficients are pretty much evident here, and likewise these are then converted into the equation which has been formulated in regression equation. And once we have put these values in the regression equation, then you can see that house price basically is equivalent to 98.24 plus 0.1097. Now here basically we have just written the model in equation form, because as it has been told to you before that there's not much of a difference between these values and the real-time values. Now here basically we are also given some additional data, but here you can see that once we know the slope, which is 0.1097, and we also know the intercept, which is 98.24, then we can draw the prediction line in this case. The equation for the above model is shown here, which may be pretty much evident to you from here. Then what is the interpretation of B0 here, which is called the intercept? Now basically this is the estimated average value of y when the value of x is 0. But again, sometimes the average value of y does not make any sense. So in that case it is vital that we basically focus on the regression variates instead of this 98.24 value, which is intercept here in this case, because intercept basically does not make much sense most of the times. So here as this house cannot have square footings, so B0 cannot be calculated, and B0 does not have any practical application here in this case. So this is the hard fact regarding simple linear regression. It's meaningless from as it can seen from here that a house won't exist with a size of 0 square feet. So basically that's why B0 is not counted much in these relationships, and we are more focused on B1. Now here in B1 you can see that basically there is a value of 0.10977. Now this is the regression variate, as they say, and the value which basically estimates the change in average value of y as a result of 1 unit increase in x. So basically it would tell us to what extent the mean value of y will get changed with the change in value of x. So here basically B1 is 0.1097, which has been calculated, and you can say that mean value of a house increases by 0.10977 into 1000, and on average for each additional 1 square foot of size. So basically based on that we can interpret some very meaningful data, and in that case we can predict, or we can look for the patterns which may be existing in real-time data and how to analyze them and how to solve that problem. So then we come to the example in which we are asked to predict the price of a house with 2000 square feet. Here what we have to do is just put the value of the price in the price column, which is shown here, and you can see that adding it up with 98.25, we can see that the value is obtained, which is 317. Now here basically the predicted price for a house with 2000 square feet is $3,17,850. So basically this is how we predict the price of a house through the tools which are given to us. Now here basically you can see that when using a regression model for prediction, we have to predict within the relevant range of data. So we cannot just extrapolate, and we cannot try to find out a value which is outside the scope of these last two values, or the bottom and top values which have been identified in correlation coefficient. So here basically you can see that we won't be able to predict the values beyond this line, and likewise we cannot measure the model implications by considering values from this line which is extended from here. So by extrapolation basically it is possible that we do be able to predict some kind of predictive figure, but that won't be advisable, and it is advisable that if you want to extrapolate beyond the range of regression line, then don't use this software at all, because this is strictly prohibited from here due to statistical reasons. Now here basically the other part is related to the relevant range for interpolation. Extrapolation is highly inadvisable, because all what we can do through the equation which we have obtained in previous slides, we can try to predict the values within these high range values. So we can try to find out the value of this data set at this specific square feet point by within the two limits here. We can try to find additional points at any point within those limits defined. But if we go beyond that and try to predict value at that point, then this is highly unadvisable, because that can end up in errors. So once we have gone through that, then the basic concept which underlies the measure of variation, and we know that the total variation in this regression analysis is divided into two parts. One is called total sum of squares, which is the mean data. then it is equivalent to the regression sum of squares, and the sum of squares which have been basically calculated through regression. And then the last one, and not the least, is related to SSE, which is the error sum of squares here in this case. Now the values for each of these sum of squares is written here, and we can basically try to find out the predicted value and any kind of value through these equations. So measures of variation basically comprise of the total sum of squares, which is determined with this abbreviation, which you can see here as SST, and then that is made equivalent to the regression sum of squares plus error sum of squares here. The formulas for all these relevant measures of variation are detailed here, and from here you can see that y bar basically is the mean value of the dependent variable, yi is the observed value of the dependent variable, and then yi naught is the predicted value of y for the given xi value. So we will discuss in detail the implications of all these concepts, and here basically you can see that here SST is the total sum of squares, and basically it measures the variation of these observed values around their mean, and this is the total measure of variation, mind you. Then is SSR, which is the regression sum of squares. Now this is very important, that this kind of variation is the explained variation, the variation which is basically explained by our independent variable which we are trying to test. So this variation is attributable to the relationship between x and y. However, it's not necessary that only one variable or whatever, how many variables which we are including, they may not be able to explain all the variation. So the variation which has been explained by some unknown variables but are not included in the model are measured through SSE, which is termed to be error sum of squares, and hence the name error. This term can be described as unexplained variation. So variation in y, in this case attributable to factors other than x, those variables which we are not considering and may be existing someplace in literature. So today in this lecture we discussed about the simple linear regression, and we discussed that what is regression basically, and from that perspective we discussed what is the primary difference between correlation and regression. Initially we discussed that scatter plot is used to have a graphical overview of the nature of relationship between any type of two variables in correlation, and in this case again in regression the situation is a bit different, because in correlation we are not told about any cause and effect phenomena between any type of these two variables. However, in regression we do know that what is the variable which is causing, and we have the specific definition of independent and dependent variable in regression case. So this was the main difference between these two, and also regression gives us more detailed overview aspect in this case. Then we had a general introduction, what is basically simple linear regression, and what are the factors which are involved in that. Then after that we had a discussion on the initial model, which is basically based on the very simple equation which most of the students have done in the past in the form of y is equal to mx plus c. Now here the whole equation was termed as y is equal to beta naught plus beta 1 x plus error term. Now here basically beta naught is the intercept and beta 1 is basically the slope which is existing. And again, slope gives us the rate of change between these independent and dependent variable, and how 1 unit increase in independent variable will cause change in dependent variable in this case. So error term again gives us the idea that in addition to the independent variable, some other variables may also be causing change in the dependent variable, and that effect is basically introduced as an error term in this case. So we had discussed the whole detailed model in this case. Then the method which is used to calculate all these regression variates and all these detailed beta naught and beta 1 is termed as least square method, and we have already discussed that what would be the interpretation of the model, how this model can be calculated through the various values which we have discussed before, and mathematically how we can calculate beta naught and beta 1. And once we know the mean and all the different aspects of these model values, which we are though given through the data set, then we can easily calculate the rest of the values. So we in this case had discussed an example in which we took the house prices and its relationship with the size of the house. And in this case we had a certain data set and we tried to find out the relevant values of the intercept and the beta 1 in this case, and what do they interpret in this case. So this example gave us a brief overview of how we would be interpreting this model, how would we be applying this model in this case. After this main least square method, though there are other methods as well, but least square method is most commonly used specifically in case of simple linear regression. Now interpretation of that model is very easy once we have calculated the beta 1, b naught and the error term, and it gives us an exact position of the data in this case. Then we had terminology introduced here which is termed as measures of variation, and in this case we discussed that there is the terminology termed as total sum of squares, because we are dealing with the sum of squares, reason being so that some of the values here which would be existing above the line and some of the values would be plotted below the line. Now if we just want to know the average of all these values, then simply taking the sum of all these values would simply nullify all these, because the positive values would cancel the negative values in this case with respect to mean. So that's why we take the squares and the sum of these squares in order to avoid the cancellation of positive values with negative values. Based on that, that's why the least square methodology is introduced and most commonly used. In this case, from that aspect, that's why when we are saying total sum of squares, and we are asking for basically the total variance which is caused by the independent variable to the dependent variable in this case. Then comes the other part which is defined as the regression sum of squares, or in other words explained variation, the variation which is caused by the independent variable, and again which the independent variable is clear-cut causing in the dependent variable. That's why it's termed as SSR, or regression sum of squares. The other term which we discussed about was related to sum of squares of errors, and as also termed as SSE, or unexplained variation. So this is a variation which has been caused by variables which we are not considering and which are other than the single independent variable which we have just considered. So based on that measures of variation, we can see that what impact each kind of variation is having on dependent variable, and it would give us a more detailed overview of the cause and effect which we want to see in this relationship. So I hope you understand this. Thank you so much. Allah Hafiz.